All right, take it away.
So can you see my screen?
I can see a bunch of files.
A whole bunch of files, yeah. So I don't have a PowerPoint. I'm going to talk very briefly and then pass over to Paul and Nathan. So I'm not going to give a long introduction to the Deposit Atlas program, because if you go to this first web address, which I hope you can see there, the smi.uq.edu.au GSQ UQ webinar series. Our webinar relating to the Deposit Atlas is there, as well as Paul Gow's one on how to put data into that survey. Can people hear me?
Yes.
Yeah, good. And the other thing that I wanted to mention was the next web link is the Northwest Mineral Province Deposit Atlas, and that's this link here, which we've shown previously. And that basically shows we're now up to about, if you add up the various different models here, about 21 different deposits for which we've created PDF Atlas volumes and 3D compilations in Geoscience Analyst. So those are available to download and look at. And again, the link is shown there and also shown on this address here. The only thing I wanted to talk about before passing over to Paul is that with now having finished about 21 of the 24 deposits that we were doing for this atlas over the last couple of years, what we'd really like to know now, and what I wanted to briefly mention here, was whether, we've got lots of good feedback on the Atlas from various different people, but we'd like to know a little bit more about how people have used it, which volumes of the Atlas they've used, and most importantly, what feedback they can give us on how to improve any new Atlas entries we produce here or elsewhere, and possible data sets that they'd like to see added to the existing Deposit Atlas entries that we've done. The great thing about the way these have been put together is that adding additional data to them and putting up a version 2 of the Atlas is a very easy thing to do. So if you look at this this final link here, there's a Survey Monkey survey, and there's also one of those QFIDs that will allow you to link to this survey that will, if you can, will allow you to talk about whether you've downloaded the Atlas volumes. If so, which ones you've downloaded, and this is for the PDF volumes, also for the 3D data compilations. And I'm not going to go through all this, but any other suggestions you had as to other improvements, other data sets you'd like to see included, any improvements to the delivery technology, and mechanisms that we've been thinking about around how we might keep updating these atlases as time goes on. So that's all I'm going to say. I'm now going to pass over to Paul Gow to actually talk about the latest 3 entries in the Deposit Atlas compilation, which came out in the last couple of weeks.
Okay, thanks. Great, great. Thanks, Rick. I look forward to seeing some feedback on those atlases. Now, Nathan, I believe, is going to put up up some slides for us. Yeah, what we're going to do, it's relatively quick today, given the chock full agenda. Is we're going to just have a run through the last couple of atlases that we've produced, some general comments up front. And then Nathan is going to walk us through the Dugald River and Roseby area to see what the deposits are like up there and some of the data we've put together. And then I'll crank up Geoscience Analyst, and we can have a look at the Kalman deposit and some data that's been put together down there. Okay, so thanks Nathan. If we can pop onto the next slide. So Rick touched on this briefly, that we're sort of nearing the end of the program of Northwest Mineral Province atlases. So we've now covered 24 of the deposits in 16 chapters, plus an introductory chapter as well. So we have 4 remaining deposit atlases to be delivered next month. So they're in train. So you can see the fair spread of those deposits across the Mount Isa inlier on that map. Not only geographically, but also in terms of the commodities that they are hosting. Yeah, next, can you pop the next slide up? Thanks, Nathan. So the 3 recent chapters that we've covered have been Kalman, Roseby, and Dugald River. I guess, well, obviously Dugald River is an operating mine. The other 2 are projects in the development phase. Kalman is I guess the resource phase. It's had a couple of mineral resource estimates completed on it. And Roseby has just earlier this month released their feasibility study. So looking at what they might be doing there. So Roseby, they're looking, for those of you who aren't familiar with it, it's a copper gold project, and it's basically a multi-pit project. So they're looking at mining from 7 open pits to produce about 45,000 tonnes of copper and 14,000 ounces of gold per year. That's life of mine average. And they have a reasonably large reserve that they've defined for their feasibility study of 171 million tonnes at 0.46 copper plus some gold there. And I guess I should add on top of that, if you want to go and have a look at any of the information, there's also a pretty significant resource. So I think resource, including reserves, is up in from memory, the 230 million tonne type area at that similar grade, probably to the reserve, I think. So it's an interesting and exciting project that's coming along. And I guess Kalman and Roseby have both flown under the radar a little bit, given their earlier stage projects. Certainly the deposit chapters that we've completed to date, the majority have been on operating mines. Look, and the third one is the Dougal River zinc lead silver mine, which Nathan is going to talk about in covering that area in a minute. And it's, I guess, a relatively new mine compared to others in the province. And you can see there it's got a reserve of about 25 million tonnes with zinc being the dominant metal there. Now there's Rick's already put this link up to our Mineral Province Deposit Atlas webpage, but if you want to go there, as Rick was showing you, you can download all of those documents and 3D models, etc. Look, I'll come back a little bit later with Geoscience Analyst, and we'll have a look at the Kalman project. But Nathan is now going to talk to you a little about Roseby and the Dugald River projects.
Okay, good afternoon, everyone. Let me just get this up. So thanks, Paul. Thanks, Rick, for the introduction. I'm just going to give a very brief overview of some of the content that's in the new Atlas updates that have come out recently, just covering Dugald River and Roseby, and as Paul mentioned, he'll go into Geoscience Analyst and take you through the Kalman Deposit. Sorry, hang on a second. So just to go over this again, Chapter 16 is Dugald River, and Chapter 17 is the Roseby copper gold prospects that are located around the same area that Dugald River is located in. Just looking at the map on the right, you can see broadly that the deposits that we're looking at today are located in the Merrill-Kathleen domain. We'll see that these are scattered around inside the Mount Roseby schist most dominantly, which is the brown unit, through the central belt here, and then Dugald River is located here within the Dugald River mine sequence. So Paul has already sort of given an overview of the kind of the types of deposits we have here. We have the copper gold Roseby projects, which are scattered around east and west of the Roseby fault, which is just a north-south trending feature, and then Dugald River, which is the large zinc lead silver mine located here, if you can see my cursor there. So just in terms of the geology, we won't go into a huge amount of detail just because of time, but you can see very briefly that east here of the Mount Roseby fault, we have the Corella Formation, which hosts 2 of the prospects from Roseby, and then the majority of the prospects are hosted west of the Roseby fault. within the Mount Roseby schist. The Dugald River Formation, or the shale member located here, which is in the Roseby schist, which is east of the Knapdale quartzite, and then the Lady Clare Formation, which outcrops further to the west. The Mary Kathleen Formation, as I mentioned earlier, is outcrops east of the Mount Roseby Fault, which is mainly the Corella Formation, and the Boomara Metamorphics as well. Moving on just to Dugald River. So for those that aren't familiar with the structure of the atlas, they're generally a compilation of publicly available information and data that's been made available from the mines or companies that own the deposits. In the case of Dugald River, we're mainly compiling information here that's been collected over the last few decades, going back to the early work of Connor from 1982 and 1990, and you can see the black and white maps here. And over the years, they've been systematically updated through a series of master's and PhD projects carried out by James Cook and UQ students, and they include Sarah Porter, Ziu from James Cook, and Mark Whittle as well. You can see as we progress along through these images, we start seeing the improvement in some of the geological maps, and the most recent work is obviously done by MMG, distributed here by Peter Cruz, who's currently doing his PhD through James Cook as well. So you can see we're gradually improving the information there. We've managed to include snapshots of most of this in the Dugald River Atlas. So again, this also correlates into the cross sections, and you can see that general improvement. Again, I'm not going to highlight too much about the geology just because of the time, but I would encourage you, if you are interested or this is an area that you're working in, that you should certainly download the atlas. There certainly is improvements, and the last image here on the right-hand side from MMG from their recent reserve and resources update highlights really clearly the lead zinc unit, which hosts mineralization, and then this copper unit above here. So it'd be interesting to see in the next few years as more work is released about those two distinctive units there. A key feature of the atlas is really visual compilations of the available rock textures and ore textures. These images have been taken from theses, and again, we definitely try and compile these in a logical way so that you don't have to constantly be chopping and changing between the different theses, and we can actually try and put these back into their deposit context. So you can see here some of the host rock features from Dugald River and a whole range of ore textures that you can see in the massive sulfide bodies through there. Paul won't be talking about the Dugald River geoscience analyst, but you can see how all of these data sets come together into the 3D model, and these are basically the compilations in spatial in true spatial coordinates of those research works or anything in the public domain as well. So you can see here the Whittle sections, the Whittle map overlaid over the geochemistry that's freely available from the GSQ as well. And also we also embed in here the geophysical data sets as well, so you can start bringing in those comparisons directly as you work yourself through these data sets as well. Moving on very briefly, I'm going to go through the Roseby copper gold deposits. As you can see from the right hand side, there is a huge range of showings. Not all of them are very well documented. Most of these are through the company reports of the various people that have owned the deposits over the years. But again, if you wanted to cast your eye over some of the resources and reserves, you can go through the main atlas, or you can have a quick look at the screen now. You can see certainly in the region of more than 300 million tonnes of ore in these various deposits. These deposits are mostly hosted west of the Mount Roseby Fault in the Roseby schist and the Cosina Formation and in the Lady Clare Formation. The style of mineralization varies between the deposits. There's two distinctive styles. There's a very familiar looking hematite breccia style copper gold mineralization. Some of these deposits, such as Leva, has similarities to IOCG style mineralization and alteration features as well. And then there's a series of copper only metasediment hosted deposits, and these include Scanlan and Blackard deposits. So again, capturing the publicly available information either from theses or from the company resources, this is an example of the Little Leva deposit geology and some of the sections that have been released, and you can see some of the styles of mineralization obviously in these very elongate lenses, lending themselves quite well to shallow open pits as well. The Bedford deposit, again, one of these more breccia style deposits of extreme linearity, showing a strong structural control on mineralization in these deposits, and contrast in some ways to the Blackard deposit. This is an example of a more sediment hosted mineralization, And again, you can see how over the years, this was a section put together by Universal Resources in 2008, and then the more recent one by CMMC in 2018, again showing some of the updated work as they develop those deposits into mines. Again, just some examples of some of the kind of the rock textures and the ore textures that we're able to compile here. These are from either from Thomas or from Niall. From some of the theses that have been done here at Lislever, you can see some of the characteristic reddening of the host rocks, classically kind of hematite, dusting, the intergrown with chalcopyrite and magnetite, very reminiscent of IOCGs in the Cloncurry region as well, so a very prospective area. Again, I won't dwell too much on these, but just a few snapshots of some of the way that these deposits have been captured in Geoscience Analyst. Obviously, we're not looking at just one deposit here for the Roseby series. There's a huge range of deposits, and Paul's done a really good job of bringing these together along with the regional data sets as well. So one of the data sets that does extend over this region is the extensive HiMap data collected by CSIRO. So that's been included in this data set. And again, obviously, all of those more detailed deposit-specific sections and features are also included for your convenience as well. So again, a bit of a quick rush through, but I think it'd be beneficial to move on to let Paul take you through the Kalman deposit through Geoscience Analyst. So again, I'll be around if you've got any questions, but I'll stop sharing now and hand over to Paul.
Okay. Look, thanks very much, Nathan. I'm just sharing my screen here. There we go. Yeah, so look, just before we, so we're going to go and have a look at the Kalman deposit now. I will just show you for reference actually where that sits. Oh, there we go. I won't do that. Anyway, you can see on this diagram quickly that that we've just been looking at the Roseby and Dugald River deposits up here to the north, and then as we come further south in the Mary Kathleen domain, we get down to the Kalman deposit, which sits further to the south here, down south of Mary Kathleen, but not as far south as Dugald. So that's where we are. I'll get the Geoscience Analyst up now and running, so we can have a bit of a look through the Kalman material. So this is where the deposit sits. We'll look straight down from on top, and you can see this is approximately about 40 kilometres across. This satellite imagery taken from Google Earth. And you can see here that this is the Kalman deposit with some of the drilling that we've taken from the public domain information. And you can see that there's essentially the Kalman deposit sits along the Pilgrim Fault, which you can see very well in the satellite imagery. So that's the Pilgrim Fault there, and then further out to the west here is the Fountain Range Fault. And in fact, if we pop on the 3D image, you will see where they sit. Okay, so this is the 3D geology from the Northwest Queensland Mineral Province 2010 study. So here we have the Pilgrim Fault with the Kalman deposit sitting just to the west of the Pilgrim Fault, or almost in the Pilgrim Fault, and then this is a big slice of Corella Formation rocks here, and then we have the Fountain Range Fault out to the west. In fact, I'll put the geology on there so we can see that. Okay, so that's where we sit. And so what we have in the Mary Kathleen domain down around this area, the rocks around Kalman are dominated by the Corella Formation. I'll turn that satellite image off. Okay, so these are Corella Formation rocks, and they're bounded by the Pilgrim Fault here to the east. And once you get east of the Pilgrim Fault, you start to get into the overhang jasperite and the Mount Norna quartzite over in the sorry, not the Mount Norna quartzite. You're over here in the Mitakudi terrain, I think it is. Now the thing to note, I guess, about the zone to the west of Kalman here is that you have the Corella Formation, but you also have these a bunch of Wonga age granites, the Overlander granites, and then you also have the Mount Philp breccia, which is typically considered a younger age breccia, I think. If you look at the work done on that, it it's called the Mount Philp breccia, but it pretty much looks like the standard Corella breccias that you see out through the Eastern Succession, from what I've seen, where you have clasts that have strong albite alteration, and then you have a mafic of, I guess, ferromagnesian minerals to a certain extent. And then some of those Mount Philp style breccias are also present in the Kalman deposit here. It's worth noting here, I guess, given allusions to a magmatic related genesis for the deposit, that you do have these Wonga age granites which are older, and I think the nearest outcropping Williams-Narraku age granite is this one down to the south here. And some dates that have come out of Kalman. I won't get into talking too much about the genetic models, etc. But there were some rhenium osmium dates from Kalman that came in at about 1475 from molybdenum there. So I guess it's typically considered to be a younger age deposit. So that's the regional geology. So to have a bit of a look at some of the other data sets we've put in here, we have the geophysics. So there have been some seismic sections completed, one to the north, and unfortunately, as it always is, the deposit is sitting right between those seismic sections. But you can see that on those is interpreted the Pilgrim Fault tipping to the east, and this is the Fountain Range Fault out here as well. So there is some regional control on the geology here in terms of the geophysical data. And then we also have those other data sets. There's detailed aeromagnetic data that's been flown through the area that gives us a good idea of what Kalman actually looks like in the magnetic data in detail. There is a magnetic high here, just to the I think it's just to the west of the main ore lenses, which I believe is interpreted as related to some volcanic rocks there. And then I won't show them now. We have the aeromagnetic and the gravity data and the radiometric data as well. So all of those data sets are in there. Next up, I guess the HIMAP. There's been some pretty extensive HIMAP surveying completed in the Isa Inlier, and one of the surveys actually runs through this area. So we put a bunch of, I'll turn the geology off there. So we've put a bunch of images in this atlas that are taken directly from the GSQ website, and the data comes from a project that was GSQ and collaboration between GSQ and Sahara dominantly, I believe. So we've taken some of their mineral maps and put them in here as well, and in this case draped them on the topography. So you can see there's amphibole chloride, epidote, your ferric and ferrous ions, etc., and your microabundances and microabundance and I obviously have two on there. Microabundance and composition, etc. So they're worth a look at your leisure. Particularly, I love looking at this HIMAP data when you put it together with the geology. I guess historically we've often looked at HIMAP as trying to map direct alteration assemblages around deposits, etc. But it's fantastic for looking at the host lithologies through areas. And so many of the minerals that you see in HIMAP are a reflection of either regional fluid circulation systems or your metamorphism, whether it's then reflecting different grades of metamorphism or in fact subtle changes in the protolith lithology. So the HIMAP data is there. The geology. Let's see what else we have in here. Oh, that sort of scale. Let's go into the deposit scale. So I'll turn that regional geology off and we'll zoom in there. So what we've done is in this case taken the public information that we could gain that has been publicly released with the drilling, and we've also taken we should have some geology here from the deposits. So we've taken those sections and plans where we could find them and put them into Geoscience Analyst as well. So you'll see that in this case, I'll turn the drilling off for a minute. If you look straight down, you can see this is a plan view of the grade distribution the Kalman Deposit. So it's north-northeast trending and a series of thinner lenses all stacked together in structurally controlled manner. And there you can see on the cross sections as well that they're pretty steeply dipping. So that geology's in there. What I might add at the deposit scale is we've been fortunate. Mark Whittle from Hammer Metals has provided us his MT data that Hammer has very recently released in the area in one of their press releases this week. This was an MT survey that was completed under the CEI, the Collaborative Exploration Initiative with the DNR and GSQ. So it's hot off the press. So thanks, Mark, for allowing us to use that. You'll see there's some pretty interesting things to think about. I'll put it so that's looking north essentially. So if we're looking down, this is the Pilgrim Fault, and this is the outline of the mineralisation zones at Kalman. And then you can, as we look horizontally, you can see where some of those anomalies sit. So it's pretty interesting data there. And as you saw from Janelle's talk earlier, is that MT is essentially imaging to large depths. So you're getting down towards about 5 or 6 kilometres here at the bottom of that section. So thanks, Mark, for that. That was that's pretty interesting data. I look forward to seeing what comes of that in the future. Now, the last thing I wanted to touch on is some of the work that Jim Austin was talking about. So what we've done is we've taken the data from the Uncover Cloncurry project that was run by CSIRO and other collaborators probably about 5 years ago, and parts of that are still going on now under the new discovery program that Jim was talking about earlier. And one of the fantastic things that's come out of that I certainly enjoy looking at is to not only all the data sets that Jim was talking about in terms of the petrophysical and the chemistry, but the TEMA images. So what we've done is put those TEMA images onto the drill holes, and they look pretty much like a speck at this distance, but we've plotted them spatially down the hole. Oh, there we go. So that you can move into that zone and see. These are, correct me if I'm wrong, Jim, but I think they're about 1 to 1.5 centimetre wide zones that have been imaged. And here you get a fantastic look at the textures and mineralogy that's in these zones. So in this case, you can see that there's actinolite, there's larger class of microcline is the orange material with some flickering of albite through them. And then you have this, presumably it's later calcite in blue coming through this zone that Jim was talking about. So I'd encourage everybody, I find it incredibly rewarding to just sit down and have a good look down through these drill holes, and you can see the textures and the alteration minerals, and they really give you a nice insight into what's happening at these deposits. Look, we could go all day. There's so much stuff to talk about, but I see it's 3:10 there. So I will stop sharing my screen and hand that on to the next person to talk. So thanks, Helen.